Okay, hi Year 12. I am going to do in this video the answers for question 4 on the Unit 6 end of topic test. So, starting with then, draw the structure of the alkene. Just remind myself it needs to have a double carbon-carbon double bond that would form 1,2 dibromo 3-methyl butane. So, I'm going to start by drawing that actually. So butane, so 1, 2, 3, 4. And then that's an alkane or halogenoalkane, so I'm going to put in all of my bonds. 1, 2, so I'm going to start from this end. Dibromo 3, so carbon 1, carbon 2, carbon 3, methyl butane. So we're looking for an alkene that's going to have a double bond between carbons 1 and 2 and it's going to have 4 carbons in the chain. So that is going to come from 1, 2, 3, 4, double bond there, and then pop in the hydrogens. Just check you've got the right numbers. 1, 2, 3 needs 1, 1, 2 needs 2. Don't just leave them blank, put the hydrogens in, and yeah, that's... Oh, no, crikey, sorry, there's a methyl group there, so CH3 on carbon 3. Okay, next question. Draw the structure of the alcohol with the molecular formula C4H10O that is resistant to oxidation. So we're looking here for a tertiary alcohol, which means if there's 4 carbons in the chain, it can't just be a straight chain, there's going to have to be some branching. So we're going to have 3 carbons in the chain, and then we're going to have some branching here. We're going to have a methyl group, and the OH group is going to be attached to the carbon, which is not attached to any hydrogens. It's attached to 3 alkyl groups, and therefore is tertiary and resistant to oxidation. Things to look out for when you're drawing your structures here is that that bond goes to the O. I know that sounds obvious, but actually it's quite a common mistake just in haste to do things like that, and that is bonded to the hydrogen, which is not correct. So just be mindful of that. Okay, question C. Draw the structure of the alkene that has a peak. Can we still see that? Yes, that has a peak due to its molecular iron MZ equals 42. So the molecular iron is basically the compound itself with a charge. Okay, it's the molecule with a positive charge, which means it's going to be 42. So if we say, just doing a calculator, 42, I'm going to say 42 divided by 12, which is the AR of carbon, gives me 3.5, which means I'm going to have C3, and then we know it's an alkene, so if we now say 12 times 3 equals 36, and then 42 minus 36 is 6, therefore we know we have 6 hydrogens. Okay, it's an alkene, that works, so it follows the formula. So C3H6 is CnH2n, which is the general formula of an alkene, and so that is going to be, and I'll draw it over the page, make sure we can see here, yeah, so that is going to be propene. Okay, next question and final question of the paper. Draw the structure of the organic product with Mr equals 73 made from the reaction between 2-bromobutane and ammonia. So let's start by drawing 2-bromobutane. Butane, 1, 2, 3, 4. I'm going to start from this end, but I could equally start from this end, doesn't really matter. And put my halogen in, and remember that where we've got a carbon halogen, carbon bonds to a halogen, we have got partial charges, that is a polar bond, and ammonia, NH3, Nitrogen has a lone pair, and so this is going to act as a nucleophile, and it will attack the partial positive carbon. You must have the lone pair. Now actually, I'm going into way more detail than you need to. This is a 1 mark question where you're asked to just give the product, but for the sake of further explanation, I'm going to do the whole thing. So that's going to attack that, and we must have our lone pair, our arrow come from the lone pair if we were being asked for the mechanism, that is. And then the electrons in this bond are repelled by the incoming electrons, and we draw an arrow from the bond onto the bromine. Okay, it's not from the carbon, it's from the bond onto the bromine. Okay, that then gives us, the bromine's gone, and we've added the ammonia. That nitrogen's got 4 bonds, so it's left with a positive charge. And so then we have a second molecule of ammonia, we do this in excess, which takes a hydrogen from the bond onto the nitrogen there, and that gives us our NH2 group. And just out of laziness, I'm not going to put all of the hydrogens in. We've also then got NH4 Br minus. Okay, so that is our ammonium salt. That's our other product that's produced. But this is the answer to that, and you can just check that the MR of that is 73. So you've got 12 times 4 plus nitrogen is 14 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Plus 12 times 4 is 73. Okay, that's it.